I want to show you on the graphing end what's actually happening when we're working with series representations of different types of functions. And so we're going to take a look here. This is the same graph that we looked at earlier, the rational function 1 over 1 minus x. And a couple features here you can notice about this thing. X is not allowed to equal 0. So you will notice here, for example, that there is an asymptote here at x equals 1. Okay, that's a key feature of this graph. Um, and it also has a horizontal asymptote. If you notice, as x approaches infinity, the denominator would get infinitely large, and that would make this whole thing approach 0. So you can see there's a horizontal asymptote here at y equals 0. All right, so the idea here is that I can write out a couple of terms of the series representation. And remember from my demonstration before, you can't just have any value of x represented by this series. Okay, for example, I did one where x was equal to 10, and we just got kind of total garbage. When we added up 1 plus 10 squared plus 10 to the third plus 10 to the fourth and so on, added up to infinity. And our formula told us we were supposed to get negative 1/9. So this actually only works for values that are near 0, specifically in the range between -1 and +1. And the more terms you use, the more accurate your series representation is going to become. So remember, the series representation was 1 plus x squared plus x cubed and so on. So for example, I'm going to graph p of x equals 1, and you can see over here this graph doesn't look very much like it. However, it does have the same functional value as the top function when x is equal to 0. So there is something in common between the two. If I write the next term out, this would be what's called a first degree polynomial representation. You'll see it does start to match the graph just a little bit along here, in a little bit of a range, a little bit less than 0 and a little bit more than 0. Okay, if I write the x squared term in, you will see that it will match it a little bit more closely. Notice it's kind of following the curve in this general region right here. If I add another term, this is called the third degree polynomial representation. You can see at this point you're getting a pretty close, basically between about between about -1/2 and about maybe 1/2 or 3/4, you're seeing that this is following the curve pretty closely. Now, if you think about end behavior, a cubic function is going to go to infinity in one direction. It's going to go to negative infinity in another direction. So once you get outside that range, values close to 0, it's not necessarily going to look anything like the other function. As you write more terms, it gets better and better and better. So if I do the x to the fourth term, for example, you can see here that the graphs match very closely in a range. If I add the x to the fifth term, they're going to match up even more closely. If I add the x to the sixth term, they are going to follow even more closely than that. And you can see that here. So it's kind of a fascinating idea, this idea that as I write out more terms of this infinite polynomial, the polynomial function will come closer and closer and closer to looking like a seemingly totally unrelated rational function, at least for values in the range of 0. And notice, by the way, it's getting more and more accurate. We can go out to almost -3/4 or so here, and it's still pretty close. And this one's matching actually pretty closely, frankly, all the way out to like 1 or even beyond 1. It's still matching pretty closely, at least for the for the even term version of this. So that's the concept. And again, in higher level courses, you'll learn how to mimic a function during close to other values of x. So like if you wanted it to act a certain way near x equals 5 or x equals -3 or something like that, there are ways to shift the function. But this one will be focused around 0, and the polynomial function should be very close to the rational function, at least for values near 0. And again, it's going to get closer and closer and closer as you write out more terms of the series. So hope that visualization gives you a little bit more understanding of the relationship that's happening between these two different functions.